Let's start. Our next speaker has 6 years of experience in test automation and supporting teams with testing infrastructure and reporting. Currently working as a consultant at Sealy Solutions in Software Automation Laboratories Unit. Please welcome onto the stage Tommi Oinonen.
Whoa. Yeah, let's get this started. Yes, I'm going to talk about stuff that I've been working for years now. And I was very, very confident when I first made the proposal for this talk that it's okay. But when it was actually accepted, then I got scared. I have to deliver, and then I have to know what I have to say. Well, I had to prepare some things because I'm going to show you things. I need to prepare those things that I'm going to show. But also when I started to think about this presentation actually, like the presentation, then I had to check what did I actually promise for this presentation. So I went to the Robot.io page. So this is what I started. This is what my proposal started with. So I was asking, like, wouldn't you want that when you run your test cases, they would be run in such order that the things that you touched, the things that you have changed before you started running the test cases would affect the way which test cases would be run first. So if you break something that is related to, for example, logging in, it would automatically run first the login tests. Would that be nice? Exactly. This is cool. This, I think, we can deliver based on what we were doing. But I wrote a lot more. A lot more text, just to take, promising a lot, a paradigm shift. More. Actually, I need to tell you about some obstacles that there were. So apparently I have to list obstacles for you to go past, and then how to get past of those obstacles. Even more. I will also actually promise to give a demo. There's a will. There will be a demo. So let's have a demo. Let's show that thing that I said. That would be cool. And I think it is cool. And I have that demo. So, for this demo, I will run something very simple, as I promised, a very simple demo. I wanted to try this with prioritizing robot framework test cases, but there are like 5,000 of them, and it's not nice for simple demos. But let's demo with a simple thing. I have one open source project. I'm a disc golfer, and I made myself a disc golfing app where I can or web application where I can mark my results. How many throws did I use? And I have test cases for them. It's really simple. So if I run the test cases, so run robot, just to take the feeling what I mean by my project. This is my hobby project that I did. There are some API tests, some basic requests, some Selenium tests. And just to mention, I'm not a tester, so I made these test cases just to try robot framework out. They took just about a minute, so not that long. But still, when I do something, it would be really, really, really nice if it first tests those test cases that are actually affected by the changes I made. So I'm hoping this should pass. Some of those test cases are a bit flaky on purpose, but I'm guessing that this will pass. Everything passed. But let's see. Let's break the application. So it's a very simple tornado application. Let's open this file, for example, here. Let's see. There are some handlers. You can actually add some images there. So there's image upload handler. Let's break that. So when I'm doing that, let's call something that doesn't exist, like function named foo. Let's save that. Let's see what were our changes. We added one function that we didn't actually implement, so this will probably fail. But it's a robot, so it will fail at runtime. So we need to run the test cases. Well, I don't want to run them all, so let's run just the most likely top 3 test cases to fail. clearing the database, starting test cases, so what will it select? Okay, so we're playing one game, okay, passed. Yeah, we're editing a course. Yeah, and then we're uploading an image. Oh, it failed. What a surprise. But it was in the top 3 test cases that it was suspecting will be failing. Let's check, would we fail all the other test cases? So where was I lucky? Let's run the rest of the test cases. So if these all pass, this was a success. Yeah, let's rerun. So now I'm running the rest of the test cases. So not the top 3 that I had selected. It's passing, passing, passing. And it will probably, hopefully, pass for the rest of them. And I wanted to do this demo first, because I have learned that I've been talking for a couple of years about this prioritization work that I've been doing. Talking, telling that, wouldn't you like to do this thing? And people are like, yeah. But I know that when I show them, they might actually know that this is possible. It's not that complicated, and it's doable. But let's see how it's doable. So that's my main point. Passed. So there was that one case, and I was able to find it. And I didn't have to tell the system that this is the test case that you should run. Okay. Back to the presentation. Now I started from the beginning. We'll skip a bit. So, this is what I do for hobby. Do some development, as you can see, for hobby. I do a lot of GitHub stuff, but still something what I have in GitHub. These are not these are work projects. So what I'm professionally, I started about 6 years ago as a trainee in Oinonen, doing consultancy around test automation. I knew nothing about test automation at that point. I know some Python coding, which meant that when I started in a project, I never actually did testing, nor did I make libraries. That was for the other people. I was tasked with some auxiliary stuff. And one of the auxiliary stuff was really related to this. Then later on, Siili bought Oinonen, so that's no longer existing. I'm now in Siili. And then in Siili, we are now under the SA Labs, or the Software Automation Labs unit, where we are trying to do things exactly like this and building on top of various frameworks and open source frameworks built the next level of test automation. But the last 2 years, I have been working on the Testomat project. That's a big European-wide project with many work packages doing many things, trying to also forward test automation. You probably have heard about it. It's a Business Finland and ITEA-funded program. But what we in Siili started to do, we started to do test prioritization. And we were doing that with a colleague of mine, Cheek Watch. Now let's look, how did I do this? And more importantly, how you can do this. The basic setup, this you probably know. We have a tester, we make changes, we compile some software that's under our testing, we run robot, we get output files. That's quite basic. So what do we need to do this? First of all, since we wanted to do something that's actually some kind of machine learning or something more intelligent, we needed data. So I can't just do this, just run it. I need to collect data. So let's see, how would we collect data? And this is what I was actually doing. I was tasked. There was running the database where we collected all the test data from the projects. And I was actually tasked to maintain that. And later in the years, I have actually rewritten it and improved it. And what we have done now is rewritten it again, but the rewritten version is now open source. And it's called the Test Archiver. I had a workshop yesterday. Thank you. I hope that this is interesting. Not going too deep in this, but it's actually just putting your test results, especially for robot. It will eat something else as well, but especially robot test cases, because robots have a lot of data that you can actually archive. We had a workshop. I can have a lightning talk just to show how it works later on. But this is very important. Well, now we have a test history. We actually had a year's worth of test history in that one project where we're trying to do this. But that, yeah, and just to show, it's in GitHub, and there's a robot framework Slack channel where you can ask more if you want. Well, to the setup, let's add. Let's collect test data to the database. But we need more. We need to know what has changed. Because just looking at change, like the history, we can usually predict that, as we in our study noticed, we can predict that if something failed, it probably fails soon again, because people are working on the same stuff. But we wanted to be more granular. This kind of prioritization has been done many times, but it usually requires a specific model data of the software and coverage of how this model is related to the actual test cases. With robot, we are usually on such a high level, acceptance testing, doing that kind of thing. There is no actual mapping between your test cases and the code, especially not the code, maybe to some features, but I'm guessing for most of you, not even the features actually. So we need metadata, and this is one obstacle that you need also get. So what kind of metadata? Everything. Especially the easiest thing that you can do is what I did. I added metadata about which Git version, with which Git hash was the software that I was running, what was the branch. Actually, I'm listing what were the changes. And if I put those alongside the metadata, put that with robot files, because you can just add arbitrary metadata to your robot files. So just a quick poll for how many you could, if you get your robot output files, I just give one random robot output file from your pipelines, would you be able to say what was the actual version of the system under test? How many could do this? It's like 10 hands. Yeah. But this shouldn't be that difficult. In my case, it was really, really easy because everything is in place and it's not compiled and everything. But this is something that's easy to do if you just do it. So pass that metadata on from when you compile stuff, bring it with your test cases and write it in your test cases so that you have a metadata as here. I have the branch, the changes, so I touch this file and this function actually. And this is easy because I can just say git diff. Well, let's go to the algorithm. So we actually managed to design a good algorithm for this use case where we don't have the actual model data, not the coverage data, just the history, what has changed, and what were the results. So think about coverage. If I touch this file, this test will break. Or actually, what we learn, if we touch this file, this test case breaks, or it was broken, and I touch this file again, and I fix it. I think this is quite strong indication that that test case is somehow related to that file, or actually testing the functionality of that file or that function that I changed. So we can actually learn from the history, thinking about these builds. So I either break something or I fix something, and we learn. So let's make a reinforcement learning algorithm that learns if I break this, if I break this or fix this, and I change this, these are probably related. And from this, we can learn some kind of a matrix of between the files or the functions or the stuff that's changing and the actual test cases, and use that for the prediction. And this is an example for our project. It's where we tested this on paper, thousands of test cases. This is just a small heat map of on the vertical there are files, on the horizontal there are test cases. And as you can see, there are some test cases that are not affected by almost any files, so the redder the more effect there is, and the vice versa. But interestingly, there are blocks, so obviously since they are ordered in path name, test cases in the same suite tend to be related to the files in the same folder. Unsurprisingly, so there are blocks, as you can see here. And interestingly, from this kind of data, you could also see there are flaky test cases. So there are test cases that are affected by everything, or sensitive test data. That might be on purpose. But test cases that are affected by every change in every file, or vice versa, there might be files that are so critical that they always break everything, so everything seems to be related to that file. Okay, we had this kind of data. started running algorithms, so basically on paper. We had a year's worth of history, so we could simulate. Let's try to predict the data. Not going deeper into these results, we were comparing. The green one is just randomly selecting test cases. The red one, no, so blue one is a comparison algorithm, so from Ekelund et al. It was like the closest one to do something similar, but we were able to improve on that. As you can see, from every measure that we were using, we were doing better, usually much, much better. And now we have published this implementation as a change engine. So basically, once we have the data, we have a change engine service where we can actually put either the history, so what we did, just feed the history there, and save that coverage data to a database, or even better, what I did in this demo, I just feed the result history directly when I was archiving the test cases, so that's also supported. So there is just an option, feed this data to change engine. And the last part, let's add something that does the prioritization. So robot is a very nice tool. You can add the metadata there. Now there's ways to save the data. You can also do the prioritization. So what was happening in that script is that I was running this robot prioritizer, which is in the, if I go back, it's here. It's one of those files. So now only for robot. What it does, it takes the changes that I have, whatever I feed it. It asks from the change engine what would be the best order to run the test cases. And it can produce just an argument file listing the test case names. Let's run the top 3. And as the file was, I was giving it an argument, give me top 3 files, or top 3 test cases. And I run them. This is the setup. And so far, everything has been open sourced. Thanks. But, as I said, this works really nicely on paper. It works. Like, considering that you don't have to actually do anything manually, it just works if you run it and just let the history collect. It gets better. So if it fails sometimes, it's a bit fuzzy data. It's not exact data. But if it works half of the time, you're really winning if you're comparing, because probably most of you are just running the test cases in the same order or random order. That doesn't help much. But this is not used anywhere on my machine, on my project. Here I actually use, I like it. It's very useful. But the people who I'm selling this are not using this. Why? Because the last obstacle is that testers are busy. I'm proposing that you should change your pipeline so that you can run different test cases every time you know. People are not that excited about this, and they're a bit cautious. It works now, my pipeline. I don't want to touch it, how it works. I'll make it dynamic, because that's the paradigm shift I'm telling. I'm not telling that you should run all your test cases in one set. I'm telling maybe run them 3 at a time. But people are not ready for that. I'm saying, be more ready for that. There are many reasons why people don't like this system. I'm just asking people to be a bit more braver in trying things like that. Try to find the time, because you actually can save a lot of time, especially if you can just run the top 10. You have 1,000 test cases, but you run overnight, for example. And then if you want to run, for example, the top 10 cases before you leave after lunch, already before the night, you can probably find the errors that you would otherwise find in the morning. So 50-50 chance we will find one error after lunch rather than the next morning. Well, one thing that will help, unfortunately, this is the only one that's not yet open source. So we had the test archive database. We're also working on a tool. So there are APIs that you can use for that. If you're like SQL, just read the database. But having this kind of tool that we called Epimetheus, because Epimetheus is the brother of Prometheus from the Greek legends. Prometheus could see the future, but Epimetheus was the one who could see the past. He's usually the example of his dumb brother, because he's not thinking ahead, he's looking at the past. But actually, let's even look at the past, because that's usually the only thing that we can look. So through Epimetheus, you will look at the past. Let's look how this service looks. I have it here. No, I need to, sorry. Stop this presentation, yes. And quickly show this same data. So we have a demo here of this service. And this is what I did. It would look like this. So I would have 2 files. I run first the top three, and if that would pass, and I would run the rest of the test cases, or in this case, I run them all. But people don't like to get reports separately. They like to get them together. So one of the neat things that Test Archiver and this service that we will at some point probably release, where you can actually browse the results, we would see. So this is how it was run. But people would like to see the same results because they are the different test cases. As you can see, we have test cases and the build numbers rising here. We would like to see them together, so it's very easy. I have only one set of test cases or test runs, but I can look at them in either this prioritized step, or I will actually collect them in the static view. Did I get it? No, like this. These are the same builds, but I just collected them together. And now the tester don't have to think about how many different dynamic files I did. Did I run each test case individually, or did I run them all together? Just collect the results together, and we can actually see all the data. This will be coming hopefully later. And we will be, from Siili and Salaus, we will be demoing this in some instances probably in the future, and if your questions about these services come us later, and I'm ready to give the really simple demo about running the test archiver as a lightning talk after this. So, the final setup, feed the data through a nice service, and it also has an API, so that can be used for many, many, many things, because I could have from the test archive view, that's what I've been working on. Collecting test data, especially from robot framework. And there is a lot of data that I can explain to you just a bit in a lightning talk later. That you can build many interesting automations from that data as well. So, last recap. 3 obstacles, 3 solutions. Collect data. There are many ways. This is one nice way, I recommend, but there are other ways to collect test data. People are doing that, I've been hearing. People are collecting their test history. Collect metadata. Lot of few people doing this, but the easiest thing is just add, for example, what was the hash, the SHA of the Git hash from which the suit was compiled. Because then you got a lot of data. These links are important. That would be the easiest thing. That was the only link that we had when we did this data. We had a year's history, and we only got the link for that one hash. And be brave. Be ready to change and make your pipelines dynamic. It will pay you, I will assure you, even though no one's yet tried it. But hopefully we will in the future. Thank you.
All right,
Yes.
questions?
Start.
Yeah. And I'm here for the rest of the day and tomorrow in the sprints.
Hi.
Hi.
Do you have a suggestion to how to use your project in case of microservices where the system under test is not just made by one project but multiple? So the relation between files and test case, it's a little bit...
Yeah. That's the point. Like, I was talking about files because that's the obvious way, but the changes could be anything. Like, I have tried this, it actually works just looking at the words in your Git comments. Unsurprisingly, there are feature names. I'm fixing this feature or making this feature. When I mention it again, let's run the same tests again. So it would work, and this tool that I was talking about, this Epimetheus, this is especially nice for collecting tests together, so you could run for those services completely independently those tests and collect them together nicely. So that's one thing that is very, very useful and designed to. It's very similar if you ever used dbbot. It's basically that, but on steroids in many ways. Yeah.
Hey, good stuff. Could you tell how you're training your model?
How I'm training our model. We can talk that later. It's basically just reinforcement learning. So just learning. We have instances, this was correct, let's learn.
Yeah, but what tools are you using?
What tools? We just built it. It's just one Python script. This is not fancy machine learning thing with some tools. It's just one Python script. Our versions were just few lines of Python. Just basically just writing those things to the database, because there's a lot of things. It will write it in a PostgreSQL database, those links, and then you can have, and actually then you have the kind of coverage data from those learned links. But we didn't use any specific algorithm from any libraries, so to say. We just implemented a reinforcement algorithm. We tried many things, but this was the simplest and working.
I had one question. You said the prioritizing and the order of the test case you do with argument files. So you have a Python file that just generates an argument file and then hand over to a robot framework.
Yeah.
Why didn't you use the pre-run modifier? Is there a reason or?
The reason, this is simple. This is more simple, to my opinion.
To write on your side or to use?
Simpler to implement, because people are not ready to use all those modifiers, but it would be easy. You could do the same thing, the same API is there, but this is so ridiculously simple. I don't need to touch the robot API, just list the test cases and add metadata. It could be done on modifier, like pre-run modifier would work. Haven't just done that. That's maybe tomorrow, because it's easy. Just the API is there.
More questions on this side? I'm looking at you. No. Anyone there? 6,000 steps today already.
Good.
Hi, great stuff. How many runs do you need for the model to be able to predict accurately?
It depends a lot. That's the thing, that we haven't tested this in many, people are not testing this. We have only a couple of instances where we have data for that data that we had. So we had a big company with thousands of test cases, tens of thousands of test cases and several teams. But unluckily, while we had the history for all those teams, there was only one team that was adding that metadata, so that we would actually know from a year back, for this test run, this was the version of the code. So that was the difficulty. But it depends a lot on what kind of application it is. But, and the one thing is, the point I'm saying, it doesn't have to be accurate. If it's just guessing most of the time, it's still better if it succeeds 1/10 of the time. And basically it will learn by it when it's doing. So why it will also work is that this is for regression testing mostly. And in regression, most test cases never fail. But they're the ones that fail, and they usually are the ones that tend to fail again and again when people break the same things. So once they have once, of course it can't know anything before it's actually failed once, but once it's seen it, then it probably can guess it. So I would say that to some extent it would work from the first go, but it will learn when you run it. But it doesn't learn if you don't collect the data and start collecting the data. Every run that you do that you don't collect the data, you're losing. This is why I'm selling this now. If this answers anything.
Hey,
Yep.
it's great to see this. I was thinking about this third obstacle that you mentioned, about the resistance to take this.
Yep.
But I was thinking that maybe a different kind of usage could be for developers, so that when we make changes, we can see what are the most likely things that we may have broken. So have you looked into that? Is it something worthwhile?
This is one thing. So that's why we built it like this, that we get that, what I sometimes call the fuzzy coverage. So it's not a real coverage data. It's not explicit. You can teach it explicit coverage data, this system, if you want. But this is the point, that you'd only have to just do things. And if you do things in like a test-driven development, you first make a test case, you run it, it fails, Then you create the feature which will fix the test case, and then you will quite explicitly learn for this system that, okay, I did this system, it fixed this, okay, these are connected, then I run all the rest of the test, let's see, did I break something old, then learning new links. So if you would do something like that from the beginning and save everything, it would be quite accurate, this model that you get. And this is one, specifically this, getting for the developers, for example, who doesn't, if there are people who are not writing the test cases, then you can get the data of those test cases by just running this algorithm, and then the developers doesn't have to know about these thousands of test cases, for example. Just get, I did this change, and I want to do something local testing, what should I try? And it might succeed sometimes and might not. And the more data you got, the better it gets.
What else kind of data you can feed then? Because usually they are in unit test, integration test, and acceptance test. Can I also plug in this to other stages?
Yeah, of course. And that's what test recovery is designed, so it's not only for robot. Robot is the one that was designed robot first, but you can do this for every other step. Usually for unit testing, it's not that interesting. And then because unit testing, for example, is so close to the source code that you can do something like this with the actual coverage data. So you need something like this. But of course, as I was having in the picture, from every stage, you could do this.
All right.
Yes.
Thank you, Tommi.
Thank you.